Alright, this is section 11.9, solving rational equations. Now we've been working with rational expressions, and now we're going to talk about how to solve equations that have rational expressions within them, and therefore they are called rational equations. Some can be solved quite simply if they are in the form of a proportion. Remember, proportions may be solved by first cross-multiplying and then solving. So here's my first example. We have two rational expressions. They're basically two fractions that are set equal to each other, and so that is considered a proportion. So in order to solve this, the first thing we're going to do is we're going to cross multiply. So we're going to take the 2x times the x, and then we're going to cross multiply and take the 3 times the 6. From there, we're going to simplify. So 2x times x is x squared, and 3 times 6 is 18. Now, once we've simplified, all we have to do is solve. So in order to solve this equation, you all know how to do this. This is nothing new to you. You're going to divide both sides by 2 because you're trying to get the variable by itself. So we end up with x squared equals 9. And since you have a quadratic and 1x squared, you can just simply take the square root of both sides, and you end up with x equals a plus or negative 3. And of course, you would want to do, you can do the check step as well. Now let's look at this problem. Again, it's two fractions, right? Set equal to each other, so it's a proportion. All we have to do is cross multiply. So I'm going to take that x minus 5 times the quantity x minus 4. And then I'm going to cross multiply and take the x plus 4 times the x minus 1. And from here I need to simplify. So you're going to use the FOIL method, right? And you're going to multiply those out, and you end up with trinomials on either side. And now we're ready to go ahead and solve. We've simplified, we've cross-multiplied, we've simplified. Now we're going to solve. And we're going to do that by trying to get all the variables to one side and the constants on the other. So here what I've done is I've taken, this is a positive 3 here, and so I'm subtracting 3. This is a positive x squared, and so I'm subtracting x squared. But I have to do the same thing, remember, to both sides of the equation. So when I do that, I end up with just a negative 4 on the right side of the equal sign. And then x squared minus x squared is 0, and a negative 9 minus 3x is a negative 12x plus 20. So we've got the variable now on one side. Now we've got to get all of our numbers on the other. So we're going to subtract both sides by 20. And we get negative x squared equals a negative 24. They're multiplying by negative 12, so we're going to divide both sides by a negative 12, and we end up with x equals 2. Remember, a negative divided by a negative is positive, so that becomes a positive 2. And we have simplified this rational equation that was originally a proportion. Now, most rational equations cannot be solved the way proportions are solved, but require finding the LCD as we did in section 11.7. And so you're going to multiply both sides of the equation by the LCD to clear those denominators. So let's look at this example here. This is not a fraction equal a fraction. It's not a proportion. In fact, it is what? It is two fractions being added on one side set equal to a constant. Okay, so this is not a proportion. So we're going to have to find the LCD and then multiply by the LCD. In this case, we're looking at the two denominators. The denominators are x and 5. They're both prime. So our LCD is going to be 5x. So I'm going to now multiply 5x times this whole thing. So that's what I'm doing. I'm taking this whole thing and I'm multiplying it by 5x. So 5x times this fraction, the 1 over x, and then 5x times this fraction, and then 5x times the 3. So that's how I've got that down below. I've just distributed that 5x. That's all I've done. I haven't done anything else at this point, is I'm just multiplying and getting that set up. All right? Okay, so now we're going to go ahead and multiply. Think of this as 5x over 1. So if I'm multiplying that times this right here, these x's cancel out, and I'm left with 5. Same thing here. This is 5x over 1. And we're multiplying it times this, right? So these 5's cancel out, and you're left with x. And then naturally on the right-hand side, 5x times 3 is 15x. So all I'm doing here is simplifying. Remember, we got 5, then they canceled out, we got x, and then 5x times 3 is 15x. After we've simplified, we're now ready to solve. So we're going to get our variables on one side. So I'm going to subtract x from both sides. And I end up with 5 equals 14x. I'm going to divide both sides by 14. And I end up with x equals 5/14. Now, you can look at the check step. If you all take a moment, turn to page 439. And look at example 11.9b. They have actually done the check step for you. And as you can tell, that check step checks out. So as you can see, when they plugged in that 5/14 into, they took this, right? They plugged it into the original equation, and then they simplified. They ended up with 3 equals 3. So that checked. All right? Now I want to make a special note here. Unlike rational expressions, rational equations do not have any excluded values to find. Remember, we're doing rational expressions, you had to find the excluded values. Well, with the equations, we don't have to find the excluded value. However, anytime both sides of an equation or a numerator or denominator of a fraction within an equation are multiplied by a variable, that's key, multiplied by a variable quantity, an extraneous solution may be introduced. Therefore, you must do the check step. Well, what did we do? We multiplied this whole thing. Remember, we multiplied this whole thing by 5x. That's a variable. So there is a chance that we could get an extraneous solution. So you need to do the check steps when it's that scenario. And in this case, it checked out. Let's look at this example here. All right. Again, this is not a proportion, so we're going to have to multiply by the LCD. The LCD, there's only really one fraction, which is 4 divided by x, so our LCD has to be x. So that means I'm going to multiply then everything by x, right? And I'm going to distribute that. So the x times x here gives me x squared. This x times this fraction here, I end up with a -4. And then the x times the -3 gives me a -3x. Once I've done that, then I can simplify, it's already simplified, and so now I can solve. And my goal is to then, here in this case, in solving, and you have to decide, remember, you've learned various ways to solve. So in this case, to solve, we're going to have to write it in standard form, factor it, and apply the zero factor property. So I'm going to move that -3x over to the other side, so it's all set equal to 0. That's standard form. Remember, ax squared plus bx plus c equals 0. That's our standard form, right? Then we're going to factor the equation. You all know how to factor that left side. And once you factored it, make sure you check your factoring, that you factored correctly. Okay, that's real important because this is where some of you will make mistakes. Go ahead and do a check real quick and make sure that you're getting your middle term and your outside terms. Then once you're going to take each factor, set them equal to 0, and solve for x. So x in this case is a -4, and x in this case is a +1. Okay, we're going to do our check step. Well, if you look on page 439 again, if you look at the example C, you see that they have plugged in a -4 into the original equation. So you have to do two check steps, right? You have to check this one, plug it in, and it checked. It ended up with a -3 equals a -3. And you got to plug this one in, and it checked also. So that means that both of these both here are the answer, right? So x can equal -4 or 1. All right? But we have to check both. We have to make sure that we're not getting an extraneous solution. All right? So in that case, it worked out. Now let's look at this example. Again, it's not a proportion, right? So the first thing we're going to do is we're going to multiply by the LCD. Well, in order to do that, to find that LCD, we have to make sure everything's factored. So the x minus 2 is prime, this is prime, but this one right here is not prime. So we have to factor it. All right, so we have to factor all of our denominators. When we factor it, we end up taking that GCF, that common factor out, all right, and it becomes x times the quantity x minus 2 once we factored it. Now we're going to look at all of our denominators from each fraction, and we're going to take one of each type, and whichever one lists the most. In this case, they have an x and an x minus 2, so that would be our LCD. Now that we know our LCD, we're going to multiply the entire equation by the LCD. So here's our original equation, and now we're going to multiply it by the x times the x minus 2. Notice I went ahead and put it over 1 because it's really going to help when we begin to go ahead and to distribute or to do the FOIL. So if I was to take this times this, what happens here is this x minus 2 and this x minus 2 cancel out, and then you're left with 2x, which is what they've got here on the next step. And then if you take the next one, all right, and you multiply this times this fraction, well, the x's, this is a factor and this is a factor. So then you're left with the 2 times the x minus 2. So that's how we got this right here. All right. So I think you're getting the idea here. I mean, this isn't new to you. You've been doing this. And then we're going to this right here times that. Well, this cancels out, and we're left with 4. And that's how we got the 4 down below. All right. We still need to simplify because we need to take this 2 times x and 2 times the -2 to simplify. We can simplify again because these two right here are like terms, so we can get a 4x minus 4 equals 4. Now that we've simplified completely, we can solve by getting the variable, by isolating that variable. All right, so I'm going to add 4 to both sides, right? And I get 8. Then I'm going to divide both sides by 4, and I get 2. All right, so what did I do here? I added 4 here, that became 0. This became 8. I divided by 4, divided by 4. That's how I got that x equals 2. And I'm moving quite fast because this stuff you should have already mastered and you already know. All right? So now we say that x equals 2. All right, so now let's go ahead and see what happens next. Did we multiply? When we multiplied, did we multiply the original equation by a variable? Yes, we did. So we've got to do that check step, right? It's always nice to do check steps just to make sure you got the correct answer. But in this case, you have to do the check step because there's a possibility that there might be an extraneous solution. So you're going to take the original equation, which I have down here. We're going to plug in 2 everywhere there's an x, which is what I've done here. And then we're going to simplify. Looking at the first fraction on the bottom, the denominator, 2 minus 2 is going to give me 0 on the bottom. 2 divided by 2 is going to give me the 1. Then we know that 2 squared is 4 and a -2 times 2 is a -4, correct? By looking at that fraction on the far right, we know that 4 minus 4 is 0. Now, what do you notice here? Hopefully you're saying, well, wait a minute, you cannot have a 0 in the denominator because that is considered undefined, okay? So you can't get a 0 like that in the denominator. So that's when you're going to stop and say, okay, the answer is no solution because 2 is extraneous. In other words, 2 gave us a 0 in the denominators. It made them undefined. So instead of saying x is 2, this would be your answer. No solution. That's your answer. No solution. Not the x equals 2. All right? So that was an example of why you need to do check steps, because you're looking for the extraneous solutions. All right, here's another one. Okay, now you guys might want to try this one. And so you might want to stop the video and try this one on your own and then come back and watch the video. All right, we need to find our LCD. Well, this x plus 3, that's prime. X minus 3 is prime, but the x squared minus 9 is not prime. It can be factored to be x minus 3, x plus 3 because it's a difference of squares. All right, so that changes what we have on the bottom. And now that we have all of our denominators are prime or factored, our LCD would be one of each type. And so your answer for your LCD is the x minus 3 times the quantity x plus 3. So that's what we're going to multiply times the entire original equation. So there's your original equation, and now we're going to multiply that by that. And remember, I always said that you could always consider thinking of this as over 1. So when you get ready to cancel here, you know that you're left with the x and the x minus 3 for that first term, right? And then you do the same process for the second term, all right? And so in the second fraction, your x minus 3's cancel. You're left with x plus 3. And then in this last one, it already had that common LCD, so that denominator is going to actually disappear, and you're left with 6. You still, now that you've done that, you're ready to simplify. So you're going to distribute the x and get x squared minus 3x. You could drop the parentheses in the x plus 3 because there's nothing to do. And now you can combine like terms. So we're going to get x squared, and then the minus 3x plus x gives you a negative 2x. Now we're going to put it in standard form, right? So what happened, what did I do here? I subtracted 6 from this side, it got 0. And I subtracted 6 here. So the 3 minus 6 gives me a negative 3. So that's how I came up with that. Now it's in standard form. You're going to factor it if you can. Remember, there's different ways to factor. All right, so just so you know. And so we're going to factor this. Again, make sure you double check your work on factoring, that you haven't made a mistake. Set each factor equal to 0. Solve for x. And since we did multiply this equation by a variable, then we have to do that check step to make sure we don't have an extraneous thing. So let's test the 3. Let's test when x is 3. So when x is 3, I'm going to take my original equation and I'm going to plug in 3. So just think about this. 3 plus 3 gave me the 6. That's where I'm getting that. All right. In the second fraction, we had 3 minus 3. That gave me a 0 in the second fraction. And then so forth. We ended up with the 0 and 6 on that in the right hand. So that's all I've done, is I just substituted in the 3. And so since we already have a 0 here in the denominator, then this is extraneous. 3 is extraneous. It's not a solution. It doesn't work. In fact, this 0 times 6 also gives you a 0, right, in this denominator. So the 3 doesn't work. Let's try testing then when x equals a negative 1. All right, we're going to take the original equation. We're going to plug in negative 1 every place there's an x. And then we're going to go ahead and we're going to simplify. So notice here that this -4 times 2 gives me a -8, but I have 6, 8. I can reduce this 6, 8 because 2 goes into both. 2 goes into 6 3 times, and 2 goes into this 8 a -4 times. So I'm actually left with 3 over a -4. And so before I can do anything on the left-hand side, I have to get a common denominator. And so we want that common denominator to be a -4. So I'm going to multiply that first fraction by 2 over 2, or a -2 over 2, because remember I want a -4 for my denominator. And so now we have -4s across the board. We have a common denominator. And 2 plus 1, now we can add those now because they have a common denominator, and we end up with 3 divided by -4 equals 3 divided by -4, right? So this here, this checks, it works. So at that point, you're going to say x equals a -1 is the only solution. So x, when x is a -1, that's the only solution. This 3 didn't work. Now you don't say no solution, okay? You just know that that one, because you had two solutions here, so you're just testing both of them, and one of them worked, one of them did not. So you just say which one is the solution, and that would be the x equals a -1. And I believe that is it for this section.